All right, let's dive into something pretty amazing.
hmm
Imagine running powerful AI models like the ones behind ChatGPT on your own laptop.
Without a fancy GPU.
Yeah, without needing a fancy GPU or racking up a hefty cloud bill.
Sounds almost too good to be true.
Right, it does. But that's exactly the kind of future Microsoft's BitNet research is pointing towards.
hmm
And today we're going to take a deep dive into just how this technology works and why you should be paying attention, even if you're not an AI expert.
Exactly. You've shared a bunch of research papers on BitNet with me, and we're going to break down the theory behind it, the potential impact, and why it might be worth exploring even for yourself.
So what exactly is BitNet? The term one-bit computation keeps popping up, and it sounds pretty radical. Is this like AI on a diet?
It kind of is. BitNet is a new way of building large language models, those LLMs we keep hearing about.
Right.
What makes it special is that it uses one-bit computation for its core calculations. Think of it like simplifying the math down to its bare essentials.
Okay, so instead of using the typical 16 bits like most of these AI models do, BitNet is crunching numbers with just a single bit.
Exactly. And that leads to some pretty dramatic reductions in energy consumption. We're talking potentially 70% or even 80% less energy compared to the standard way of doing things. It's a huge leap forward in efficiency, like going from those bulky 45 millimeter chips to the super efficient 7 millimeter ones.
That's a pretty compelling argument for going bit-sized, so to speak. Less energy means less heat, longer battery life if you're running it on a laptop, and a smaller carbon footprint overall. But what does this mean for the average person? Why should they care about one-bit computation?
This is where it gets really interesting. Remember how we talked about running powerful AI models on your own laptop? That becomes a real possibility with BitNet. It democratizes access to AI in a way we haven't seen before. You don't need a supercomputer or a cloud subscription to experiment with these models.
So students, hobbyists, small startups, they can all get in on the AI action without breaking the bank.
Exactly. And it's not just about cost. BitNet is also more environmentally friendly, which aligns with the growing concern about the energy consumption of AI.
That's a really important point.
Yeah.
But isn't the human brain incredibly efficient too? Is there a connection there?
There actually is. The idea of using such simplified calculations for something as complex as language processing is partly inspired by the brain. As Bill Gates once said, all the neurons in the brain that make up perceptions and emotions operate in a binary fashion.
Wow. That's pretty mind-blowing. So by going back to basics, back to the ones and ours, we're essentially tapping into a more fundamental way of processing information, one that's closer to how our own brains work.
That's a great way to put it. And the researchers at Microsoft have taken this idea even further with something called BitNet B1.58. It's a more advanced version of BitNet that uses a ternary system, meaning it uses -1, 0, and 1.
So not just on or off anymore, we're adding a maybe into the mix.
Exactly. It's like adding a new shade of gray to a black and white image. You get more nuance, and surprisingly, this makes it even more efficient while still maintaining performance on par with those full precision models.
Okay, now that ISAS interesting, you'd think that simplifying things down to this level would mean sacrificing performance. But we're getting more efficiency A&D comparable results. Sign me up. But hold on, we keep talking about these large language models, the LLMs. Don't they get incredibly complex as they grow? Can BitNet keep up as the models get bigger?
That's a great question, and it brings up the concept of scaling. What's exciting is that BitNet seems to follow a similar scaling law to full precision models. That means as the model size increases, the performance improves in a predictable way.
So it's not just a neat trick for small models. It has the potential to power the next generation of truly massive LLMs.
Exactly. And here's another encouraging thing. BitNet is designed to work with the popular open source components and software that are already being used for LLMs. It's not some niche thing that's difficult to integrate.
So developers can easily adopt it and start experimenting with one-bit LLMs without having to reinvent the wheel.
Precisely. And to make things even easier, there's already work being done on something called bitnet.cpp.
Okay, bitnet.cpp. That sounds pretty techy. What is that exactly?
Think of it as a toolkit specifically designed to unlock the power of BitNet on CPUs. The CPP part hints that it's built using the C++ programming language. It's all about making BitNet inference fast and efficient even on those computers without dedicated GPUs.
So you're saying that with BitNet and this bitnet.cpp toolkit, anyone with a decent computer can start exploring the world of one-bit LLMs. No expensive hardware required.
That's the idea. They've even run tests showing it's significantly faster than using standard methods on CPUs, like something called llama.cpp. And of course, it uses far less energy, too.
This is starting to sound like a real game changer,
Yeah.
but let's be honest, I'm still a little skeptical. We're talking about simplifying things to an almost unimaginable degree. Can these one-bit models really deliver the same level of quality as their full precision counterparts?
That's the million-dollar question, right? And I have to admit, I had my doubts too. But the research is pretty compelling.
Okay, I'm all ears. Give me the good stuff.
Uh,
What kind of results are we seeing with these one-bit models?
well, they've put BitNet B1.58 through its paces using some of the standard benchmarks for language models. You know those tests that measure how well an AI can understand and respond to complex prompts like Hella Swag and Winogron?
Right, those are the ones that try to assess an AI's common sense, how well it can grasp the nuances of language and context.
Exactly. And they've compared BitNet B1.58 head-to-head with those full precision LLM models, the gold standard in the field.
Right, spill the beans. How did BitNet stack up against the big boys?
The results are pretty remarkable. Starting from around 3 billion parameters, BitNet B1.58 matches the performance of its full precision counterparts. It's almost as if the ternary system unlocks a level of sophistication that compensates for the simplified calculations.
Hold on, you're saying that not only is BitNet faster and more efficient, but it's also just as good at understanding and responding to complex language tasks as those massive, energy-hungry models.
The evidence suggests that's the case. And remember, this is still early research. Imagine where things will go as they continue to refine BitNet and optimize the software.
Okay, you've officially blown my mind. This isn't just about making AI a bit more efficient. We're talking about a potential revolution in how we build and deploy these powerful models.
I think you're right. BitNet could be a real game changer, not just for AI researchers, but for anyone who wants to explore the possibilities of artificial intelligence.
This deep dive has been a whirlwind so far, and I feel like we've only scratched the surface. What else can you tell me about the inner workings of BitNet? How does it actually manage to achieve such incredible efficiency without sacrificing performance?
Well, one of the key techniques they use is something called sub-LN, which stands for sublayer normalization.
Sub-LN. Sounds like something out of a science fiction movie.
It might sound complicated, but it's essentially a way to keep the model stable during training, even with those simplified one-bit weights.
Okay, so even though we're simplifying the math, we still need some sophisticated techniques to make sure the model doesn't go haywire during training.
Exactly. Think of sub-LN as a sort of safety net that prevents the computations from becoming unstable.
And does this sub-ELN thing work well, even as the models get bigger and more complex? Can it handle the big leagues?
That's a great question, and the researchers have actually compared sub-LN to other techniques like pre-LN, which is commonly used in training large language models like GPT. Interestingly, sub-LN seems to be more robust even as models scale up.
That's reassuring. I wouldn't want my AI assistant to suddenly go rogue because it couldn't handle a complex task.
Huh.
But let's go back to those ternary weights in BitNet B1.58 for a moment. How do they actually choose which weights get assigned to Monish 1 of 0 or 1? Is there some secret formula?
It's not exactly a secret, but it is pretty clever. They use a method called mean quantization, which essentially takes the average absolute value of all the weights in the original model and uses that to scale everything down to those 3 values.
Mean quantization. It sounds like something out of a science fiction novel, but it seems to work.
It does, and what's interesting is that the distribution of those ternary values ends up being pretty close to uniform. It's like the model is finding a balance between representing information with those simplified values.
You know, what strikes me as really interesting here, they're actually training these BitNet models from scratch using these simplified 1.58-bit values. I would have assumed they'd start with a fully trained, high-precision model and then try to compress it down to 1 bit right.
That's a typical approach with what's called post-training quantization, or PTQ. You take an already trained model and try to make it smaller and more efficient.
But that doesn't work well with 1-bit models.
It turns out that PTQ works pretty well when you're going from 16-bit precision down to 8 bits or even 4 bits, but when you try to go all the way down to 1 bit, you lose too much information.
It's like trying to cram all the details of a high-definition picture into a simple black-and-white sketch.
Exactly. So they found that it's actually better to train the BitNet models from scratch using those 1.58-bit values.
It's like letting the model learn in its native language right from the start, rather than trying to translate a complex idea into a simpler form after the fact.
That's a great way to think about it. And the results speak for themselves. By training from scratch, they're able to achieve performance that rivals full precision models while reaping all the benefits of that incredible efficiency.
This is truly groundbreaking stuff. I'm already imagining all the possibilities this opens up. Imagine personalized AI assistants on our phones, running complex simulations on laptops, or even bringing advanced AI to remote areas with limited access to computing power.
And that's just scratching the surface. We're talking about a fundamental shift in how we think about AI. It's no longer just about bigger and more complex models. It's about finding elegant and efficient solutions that can democratize access to this powerful technology. And that's just scratching the surface. We're talking about a fundamental shift in how we think about AI. It's no longer just about bigger and more complex models. It's about finding elegant and efficient solutions that can democratize access to this powerful technology.
This deep dive has left me with more questions than answers, but in a good way. It sparked a whole new level of curiosity about the future of AI. What other avenues are the researchers exploring with this one-bit approach?
Well, one area that's particularly intriguing is the potential to bring powerful AI to edge devices, things like smartphones, tablets, and even those tiny embedded systems you find in all sorts of gadgets.
Edge devices. So we're not just talking about running these models on powerful servers in the cloud anymore. We're talking about bringing AI directly to the devices we use every day.
Exactly. The idea behind edge computing is to bring the computation closer to the source of the data. So instead of sending your data to the cloud to be processed, you process it right there on your device.
That makes sense, especially for things like privacy and speed. But aren't those edge devices pretty limited in terms of processing power and memory? Can they really handle the demands of these complex AI models?
That's the traditional thinking, but BitNet is changing the game. Remember all those incredible energy savings and reductions in memory footprint we talked about? Those advantages suddenly make it feasible to run powerful LLMs on devices that were previously considered too underpowered.
So we could have AI assistants on our phones that are just as capable as the ones running in the cloud, but without needing a constant internet connection.
That's the vision. Think about the possibilities: personalized language translation, offline medical diagnosis, even AI-powered creativity tools, all available right at your fingertips, anywhere, anytime.
Now that's what I call empowering. But you know what really excites me about this? It's the potential to bring AI to parts of the world where access to powerful computing is limited.
That's an often overlooked aspect of this technology. We tend to focus on the flashy applications in developed countries, but the impact of BitNet could be even greater in regions where resources are scarce.
Imagine AI-powered educational tools for remote villages, agricultural guidance systems for farmers, or even healthcare diagnostics in areas without access to doctors. The possibilities are truly inspiring.
It's about bridging the digital divide and empowering individuals and communities with the tools they need to thrive.
This is all starting to paint a very optimistic picture of the future. But I have to ask, are there any challenges or limitations to this whole one-bit AI approach? It sounds almost too good to be true.
Of course, no technology is without its challenges. One area that requires careful consideration is the development of specialized hardware that can fully unlock the potential of one-bit computation.
So while BitNet can run on existing CPUs, it's not quite reaching its full potential yet.
Think of it this way. Current CPUs are designed to handle a wide range of tasks, but they're not specifically optimized for the unique demands of one-bit AI.
So we need a new generation of chips that are tailor-made for this new kind of computation.
Yeah.
Chips that are incredibly efficient and designed to handle the massive parallelism of these AI models.
Exactly. Imagine processors that are optimized for those simple one-bit operations using far less energy than traditional chips. That's the next frontier, and the researchers are already calling for a collaborative effort between hardware and software developers to make this vision a reality.
This feels like the dawn of a new era of computing, where efficiency and intelligence go hand in hand.
Yeah.
It's exciting to think about the role BitNet will play in shaping this future.
It's a reminder that true innovation often happens at the intersection of different fields. And in this case, the fusion of AI research with hardware design could lead to some truly remarkable advancements.
This deep dive has been a whirlwind of information, and I feel like I've only just begun to grasp the implications of BitNet. But what's clear to me is that this is more than just a cool technical trick. It has the potential to change the landscape of artificial intelligence in profound ways.
It's about thinking differently, challenging assumptions, and pursuing elegant solutions that can have a real impact on the world.
I'm already eager to see what the next breakthrough in this field will be, and I have a feeling BitNet will be at the heart of it. But for now, I think we've earned ourselves another little break to let all this sink in.
I agree. We've covered a lot of ground and there's still more to explore. We'll be back shortly to wrap up our deep dive into the world of one-bit AI and talk about what it all means for you, the listener.
Stay tuned, everyone. The best is yet to come. All right, we're back for the final part of our deep dive into BitNet. And I have to say, my head is still spinning from all the possibilities we've discussed.
It's a lot to take in, isn't it? We've gone from the basic idea of one-bit computation to exploring how it could revolutionize everything from the models themselves to the hardware they run on.
And it feels like we've been on a journey through the future of AI. And I'm not sure I'm ready to come back down to earth just yet. But before we get too carried away with all the what-ifs, let's bring things back to the present. Why should our listeners, who might not be AI researchers or computer scientists, care about all of this? What's the so what of BitNet?
That's a crucial question, isn't it? At the end of the day, it's about how this technology can impact people's lives. And I think what BitNet represents is a fundamental shift in how we think about access to and applications of AI. It's about breaking down the barriers that have traditionally limited who can use and benefit from this incredible technology.
So it's not just about making AI more efficient, it's about making it more inclusive.
Yeah. Exactly. Think back to all the potential applications we've touched upon. Personalized AI assistants on our phones, AI-powered tools for creativity and education, even bringing AI to parts of the world with limited computing resources. These aren't just abstract ideas anymore. They're becoming real possibilities thanks to the efficiency gains of BitNet.
It's almost like we're on the verge of an AI renaissance, where this technology moves out of the realm of research labs and tech giants and into the hands of everyday people.
That's a great way to put it. And when you empower individuals with powerful tools, you unleash a wave of creativity and problem solving that can have a ripple effect throughout society.
It's like giving everyone a superpower. Who knows what amazing innovations will emerge when AI is no longer limited by cost complexity or access to specialized hardware.
That's the beauty of disruptive technologies like BitNet. They have a way of upending the status quo and creating a whole new set of possibilities.
Yeah, I'm starting to feel a genuine sense of awe and excitement about the future. It's as if we're witnessing the birth of a new era where AI is no longer something we fear or marvel at from a distance, but something we actively engage with and shape to our needs.
And that's perhaps the most important takeaway from our deep dive. It's not just about the technical innovations themselves, it's about the human potential that's unlocked when we make these tools more accessible and easier to use.
It's a powerful reminder that even in the face of seemingly insurmountable challenges, there are always new solutions waiting to be discovered if we're willing to think differently and push the boundaries of what's possible.
And speaking of pushing boundaries, here's a thought to leave you with. What if the next big AI breakthrough comes not from a well-funded research lab, but from someone tinkering on their laptop, inspired by the idea that even the most complex problems can be solved with a little bit of ingenuity and a lot of bits?
That's an inspiring thought. BitNet is showing us that powerful AI doesn't have to be exclusive. It can be for everyone.
And that's why I encourage you, our listener, to explore BitNet further. Don't just be a spectator in this AI revolution, jump in. There are resources available online, open source code to experiment with, and a whole community of people who are excited about the possibilities of one-bit AI.
You heard it here first, folks. The future of AI is being written right now, and you have the power to be a part of it. Maybe you'll be the one to come up with the next groundbreaking application, or discover a new way to make these models even more efficient.
The possibilities are truly endless, and that's what makes this field so exciting. So go forth, explore, experiment, and see what you can create with BitNet.
This has been The Deep Dive, and we hope you've enjoyed this journey into the fascinating world of one-bit AI. We'll see you next time for another deep dive into the cutting edge of technology and ideas. Until then, keep learning, keep questioning, and keep pushing the boundaries.